Okay, Bismillahirrahmanirrahim. Assalamualaikum and good evening to all of you. In this video, I will explain on how to do the beam design based on this key plan. Okay, I will design, let's say, this beam. I already explained to you before about this beam, but it's okay. I will repeat it again. So I hope you can follow my step. Okay, I select this beam FB2. Okay, FB2, and then the size is 200 times 500. So first of all is I have to create the free body diagram. Okay, like I show here the free body diagram, and I have to determine the loading acting. Okay, the possible loading which will acting on the beam. So our free body diagram shall be like this one. Okay, let me rotate. Okay, so this is our beam. Okay, I hope you can help me with your calculator. Okay. Okay, I hope you can do this one. Okay, you can check with your uh, beam design. Okay. Okay, so you just consider the rectangular sections. Okay, 200 times 500. Okay, and then the free body diagram is like this one. Okay, this is your free body diagram. The distance is equal to 6.5, 6, and 6 meter. Okay. So here is your free body diagram. Okay. So it's better for you to if you can before you do your design, you must show the position of your beam. Let's say you have just a simple maybe screenshot, or maybe you can finalize. Maybe you can sketch this part. Okay, so I know your what I mean, I know the condition of your beam. Okay, so let's say this one. Okay, I just print screenshot. Sorry, but it's better for me to rotate again. Okay, this one I just screenshot, then I show my sorry, before I do this, I do the screenshot first. It's okay. So I do this here. Then I crop. So I show the position, the key plan. Okay. Okay. So I show the position of the beam. Okay. So I know what is around my beam. Okay. So I show the beam is here. Okay, this is the beam. Okay. I cloud. Okay. So the distance is about okay 6.5 meter, 6 meter, and 6 meter. So I can use the formula to calculate the bending moment and then the shear force. And then so what I have is grid line number A, B. Sorry, I wrote it again. Okay, here. Grid line 5, 4, 3, and 1. So it's okay. So here is the grid line number 4. Sorry, 5. Okay, so here is 5. You can stop me. If you don't understand, you can stop me. Okay, and then, so what is the possible loading? The possible loading is the first. Okay, I don't have to. I don't want to do the table here. Okay, let me just do based on the color. Okay, so the table loading, the possible loading. Let's say this one loading on beam. Okay, so this color is safe weight of beam. Okay, so the safe weight of the beam Okay, we are talking about okay, this is the GK. Okay. GK. Okay, this is the safe weight of the beam. Okay, and then what else? Any opinion? The loading on my beam? Do I have the brick wall here? You think?
Yes.
Yes, I have the brick wall here. Thank you very much. Okay, so the brick wall here is also the GK. So here is the brick wall, also as the GK. Okay, the whole beam, I have the brick wall. Okay, any other loading?
Slab.
Okay, from the slab. Okay, let's say I use this color. Okay, as the slab. Green lah, green color. Okay, slab. Slab is a GK. GK, which is the safe weight of slab plus the permanent action. Permanent actions means the finishing. Maybe you have a shielding, okay, under your slab, and maybe M&E, okay, mechanical, electrical, maybe the lamp, the fan, and so on. So the slab, okay, I have the slab here, but the shape of my slab is shall be, this is 6.5. 6.5. This is, so the shape here is like this one. Okay. Okay, and this is 6 meters, 6.5. So this one is the triangular, and then this is a trapezoid. So here is also similar, the 6 meter. So this is how I transferred the load to my okay, let's say this is also, okay, this is all is the bedroom. So that's why I asked you to do the GK is equal to 1.5 kilonewton per meter square, and then the QK, let's say 2.0 kilonewton per meter square for all. So I will transfer the loading later based on this one. Okay, this is a triangular in shape. Okay, this is the shape is triangular from the slab. If you got this beam, so the shape will be trapezoid here. Okay, trapezoid. It's okay. It doesn't matter the shape now. The value is the most important. Okay, so the shape will be here, triangular from the slab. This is the dead load of the slab. Okay, but it's okay. We can simplify and we can change the shape to be UDL. Okay, change the shape to be rectangular shape or the UDL. Okay, and then from the slab we also have this one. Okay, the slab of QK, the live load. Okay, also the following the similar shape, but we can simplify to rectangular. Okay, so we simplify to the rectangular shape. Okay, I hope you understand. Okay, what I'm trying to teach you now. Okay, so any question? Okay, so you have everything here. So your characteristic, I mean the design data you determine by your own. Okay, you decide the concrete grade, the FCK. So by your own lah, either C25/30, and also you have C30/37. FYK is equal to 500 Newton per millimeter square. The concrete density is equal to 25 kilonewton per meter cube. And then what else? Maybe the diameter of main bar, diameter, okay, whatever. Let's say you want to use 20, diameter of link, maybe 8 mm. Okay, and then what else? T nominal, okay, you determine by yourself. Okay, let's say 30 mm here in my case. And then what else? Okay, and then so the first step. Let's say A is action on beam. Okay, this is how to determine the action. So what you have? You have the first one is the GK. So the GK from the safe weight of the beam. Okay, first is okay, I by color. Okay, safe weight of beam. How to do? Equal to your B times your H times your concrete density. Okay, so can you help me now? Use your calculator. 0.2 times 0.5 times 25. So what is the value of GK?
2.5.
2.5 kilonewton per meter. Okay. And then what else? What else you have?
Brick wall.
Okay, the brick wall. Okay, the brick wall is a bit tricky, but it's okay. But you must understand. Dari satu group saya tak boleh ni saya sangat tak boleh ni. Sebab saya dah terangkan brick wall ni masa tekla tu. Sama dengan is a clear length times 3.0. Okay, what is your clear length? Clear length is your, let's say here, okay, I sketch here. This one, semua dah ada dah ni. Dalam masa saya dah terangkan dah masa you punya ni. Okay, masa you punya tekla. Alah. Tekla. Okay, let's say from floor to floor height is equal to 3 meters. Okay, let's say, kemas sikit lah. Okay, let's say this one. Okay. Okay, so this is your, I show you again. Okay, this is your column. Here is your column. And then here is your beam. Okay, let's say I enlarge this is the width of your beam at the roof. This is beam at the first floor, and then this is the beam at the ground floor. Okay, so the distance of the floor to floor height, let's say here to your foundation is, let's say, 1.2 meters. And then here from the top, okay, this is your ground, and this is your first floor, and this is your roof level. Okay, so here to here is, let's say, from ground to first floor, let's say the height is equal to 3.0 meters. Okay, from roof to the first floor also 3.0 meters. However, you have the beam. Let's say your beam. Okay, I'm talking about the first floor. So the roof beam here, just assume as, let's say, 450 mm. So what is the clear length? Here is the clear length. Here is your clear length. This is the clear length. Equal to?
2.55.
Okay, 3.0 minus 0.45. Okay, here, the length here, 3.0 minus 0.45. Simple mathematics. So it's equal to 2.55 meter. So, okay, here the clear length is 2.55. Times 3.0, because the weight of the weight of the brick wall is here. For every 1 meter height, and every 1 meter run, 1 meter, the loading is equal to 3.0 kilonewton per meter. Okay, so that's why you have to multiply with the clear height, and then we just intend the unit as per meteran. So this is for, let's say, 115 mm thickness. Okay, including the plaster and including the painting. Okay, this is okay. Maybe you can take lesser value. Okay, 2.6. It's okay. 2.8 is also okay. Depend on the materials, but 3.0 is conservative. Okay, just use it. Okay, so what is the value here?
7.65.
Okay, 7 point, let's say let make it 7.7 kilonewton per meter. Okay, what is the another materials? Okay, slab. Yes, GK of the slab. Okay, this one. Slab. Okay, first ada dia punya safe weight is equal to, let's say the thickness 0.175 times 25. This is the thickness of the slab, HF, and then this is the concrete density. So what is the value now?
4.38.
4.4, let's say 4.4 kilonewton per meter square. And then the permanent, okay, since this is the first floor, I use 1.5 kilonewton per meter square. So what is the total? 5.9, okay, kilonewton per meter square. So you can help me to use this equation because my shape here, I show you. Okay, the shape here is, I rotate again. Okay, the shape here is, triangular. Okay, the shape here is triangular. Okay, triangular. So you can help me by using this equation. W is equal to NLX over 3 here. This one. Okay. If my case is a trapezoid, you can use this equation. Okay. W is equal to NLX over 6. Okay, multiply by 3 minus LX over LY to the power of 2. Okay, you can screenshot now this equation for this one. Okay, this is simple. Okay, so for my case, since my loading is triangle, so W is equal to, okay, let's say W for slab, okay, and LX over 3 equal to 5.9 times my LX is equal to LX is the shortest, okay, 6.5, okay, also 6.5. Okay, 6.5 divide by 3. Okay, what is the answer now?
12.8.
5
12.
12.8. Okay, kilonewton per meter. Okay, so here I have here is 12.8. But here the LS is shorter, so I might have a lower value. But it's okay since the difference is not too much, so I just use the maximum one here. Okay, I just use the maximum one here. If you use for this span, for span number 3 to span number 4, the LX is 6.0. So here LX should be 6.0. What if I change this one to 6.0? Can you help me?
11.8.
11.8. So it not not much. Okay, so not so significant. So I just choose this value. Okay, so the total GK is equal to this one. Safe weight. Okay, 2.5 here. Okay, 2.5 here the safe weight, and then 7.5 the brick wall, and then this from the slab. Okay, so 2.5 plus 7.7 plus 12.8. So what is the value?
23.
23 kilonewton per meter. So this is my unfactored. Okay, unfactored mean serviceability limit state. Okay, unfactored. So so we have another one is the slab. Okay, slab imposed load is QK is equal to let's say 2.0 kilonewton per meter square. You use these similar equations. You use similar equations. W slab, GK is equal to NLX over 3 is equal to 2.0 times 6.5 divided by 3. So what is the answer now?
4.3.
Okay, 4.3 kilonewton per meter. Okay, so your free body diagram should be like this one. Okay, this is your new complete with loading here. So I simplified. This is number 5 kan? 5, 4, 3 and 1. Okay, this is your latest free body diagram. 6.5, 6.0, 6.0. So the value of let's say live load is, okay, I use this color, live load. Sorry, the dead load here is sini je lah ya, sama je lah. Okay, GK is equal to tadi 23 kan, 23.0. Okay, 23.0 kilonewton per meter. And then I have the QK is equal to 4.3 kilonewton per meter. Okay. To ease your work, just select the beam without the point load. Okay. So that's why I'm not selecting. Let's say if I select this beam, means I have to deal with the point load from FB11 and FB9. So I choose the easiest one. Okay. So now it's time to B is step B is bending moment and shear force. Okay. So since in my case, I can use the equations because the distance or the span, okay, the difference of the span is not more than 15%. Let's say the span of 4 to 5 is equal to 6,500 and span 4 to 3 is equal to 6,000. So the difference is this is how to calculate the difference. Okay, divide by the shortest. So 500 divided by 600. So what is the value now? The difference. Percentage. Times 100.
8%.
Okay, around 8.3%. Okay, 8.3%. So lesser than 15%. So we can use the equation. Okay, I show you the equation. Please give full attention. Okay. Okay, you can refer to this. Okay, so you can okay, here also you can see the equation. And then this is for your, okay, this is for kan table ni kan. Okay, for this table. Okay. So make sure, so you have to FL, okay. But be careful to using this one is your F is the total design ultimate load. Okay, so the factor is for Eurocode. By using Eurocode, the factor is 1.35 GK plus 1.5 QK. Okay. Okay, so this is our table. You can refer to this one. Okay. So our bending moment should be like this one. Okay, you help me to calculate the bending moment and the shear force. In case you calculate by using the moment distribution method, you are allowed to use the Excel. Okay. Okay, I give you permission to use the Excel or any other software to help me to help you. Okay, so this is the your bending moment shall be, let's say bending moment. Okay, this is your span. Okay, so your bending moment will be like this one. Okay. This is yours. Okay, and then okay. Any question up to now? 5, 4, 3, 1. Okay, so at the middle of exterior support, okay, first exterior support, the bending moment is 0.09 FL. Okay, here. Bending moment here is M. Moment here is 0.09 FL. So can you help me with your calculator? 0.09 times your F. F is equal to, sorry, loading. Sorry, you have to calculate first. Okay, sorry. Before you calculate your the value of bending moment, you must calculate the ni. Okay, here. It's okay, never mind. Okay, here. Your bending moment, your F first. Okay, calculate your F. Okay, 5, 4, 3, 1. Okay, then your F. Okay. Fine. F is equal to WL. Okay, L is your corresponding span. Okay, from here to here is 6.5. Here to here is 6.0. Here to here is also 6.0. So can you help me to calculate the F? What is the value of F here at the span number 1? F is equal to tadi berapa? W tu kan? We calculate our W first. Our W is equal to this one. Okay. Our W is equal to 1.35 GK plus 1.5 QK. This is ultimate limit state. Okay, if the serviceability limit state, the factor is 1.0 GK plus 1.0 QK. Okay, you must remember these two. Okay, and then, okay, since we are dealing with ultimate limit state, so 1.35 times 23 plus 1.5 times 4.3. So what is our value of W?
37.5.
Okay, thank you. 27.5 kilonewton per meter. Huh?
37.5.
Okay, thank you. 37. Okay, 37.5. I hope you still here to hear this one. Okay, this is very, very important class. Okay, the tips is very important. So 37.5 is equal to 37.5 times 6.5. So what is the F for span number 1?
243.75.
243.75.
Sorry, 243.75.
243.
4.8 lah 0.8 kilonewton. Okay, for span number 2, this will become the F for this span for both spans. F is equal to 37.5 times 6. So what is the value?
225.
Sorry?
225.
225.
225. This one, Okay. So you use the corresponding F and corresponding L to determine the bending moment. So for the first one is equal to 243.8 multiplied by L. Our L is 6.5 meter. Okay, here 243 and then 6.5. So what is the value of bending moment at mid span of the exterior?
142.6.
Okay, good. One. Okay, I use the red color. Red color lah. 142.6 Newton meter. Okay, so what is the value of the okay, we calculate one by one lah, tak apa. Okay, so here at middle of interior span 0.07 FL. Okay, middle of it mid span of is here is equal to 0.07 FL. So equal to 0.07. Our F is second. Okay, 225 is our okay, 225 is our F and the L is equal to 6. So what is the value of bending moment here?
94.5.
Okay, 94.5 kilonewton meter. So, and then here at the okay, here, so similar, near middle of end span, also 0.09 FL. Okay, so the bending moment now is equal to M is equal to 0.09 FL equal to 0.09. Our F is 225 times 6. So what is the bending moment here?
121.5.
121.5 okay, kilonewton meter. Okay. So and then at the first interior support, okay, this is considered as first interior support, number 4, and number 3 also considered as the first interior support. Okay, consider this one. This is interior support, interior support. This is the end support. Okay, outer support, outer support. So this is also number 1, also outer support. So this is from right. This is the first. From left, this is also the first. So we use the calculation 0.11 FL. Okay, bending moment here at the top is okay, but moment here is equal to 0.1. Okay, 0.11 FL equal to 0.11 our F. So we just choose the critical one. We just choose between span 5.4 and 4.3. We choose the critical. So the critical is 243. 243. Oh, sorry. Okay, we just choose one. 243.8 and then L is 6.5. So what is the value of bending moment at support?
174.3.
Okay, 174.3 kilonewton meter. And then here at this support, M is equal to 0.11 FL. So it's similar 225. For this case, it's easier to calculate 225 times 6. So what is the bending moment here? Okay, can you help me?
148.5.
1?
148.5.
Okay, kilonewton meter. Okay. So you have bending moment and then you have the support. As well, I mean you have bending moment, and then you can calculate the shear force. Okay, I hope you can calculate the shear force. Okay, so here it's okay. Maybe we can calculate later. So we can nak calculate sekarang ke? Sekarang je lah ya. Tapi kita baik lambat lah, tak apalah. Okay, and then here is your okay, the shear force. Okay, you help me with your calculator. Okay, the shape of your shear force is typical like this one. Okay, so the shear force here is, sorry ya. Tak apa. Alah. Tak apalah. So the shear force here is equal to V is equal to at the support. Actually, you just want the maximum one. Okay, so you just check for the maximum one. Okay, what's maximum is 0.6 F. So you just calculate here the value here. Okay, the maximum is 0.6 F. Okay, which is here V max is equal to 0.6 F equal to 0.6 times the F. Your F is you select the maximum one. Okay, your F now here for this pen 243.8. Okay, your F is 243.8. So what is the value of V?
146.3.
Okay, 146.3 kilonewton. So this is the maximum. So you just design based on the maximum one, and then you apply to other part. Okay, and then your step number what ya? Action on beam, then bending moment. Step number 3 ya. Step number 3, step C is okay. Step C is
Deflection.
deflection.
VRDC.
Design ni lah, design reinforcement dulu. Kan? Design reinforcement. Okay, so you pilih lah span, which span you nak. You can design based on, yeah, let's say I design because this is too much. Okay, this one. Okay, let's say I use color. Okay, I use color. This is A. This is B, let's say as a, and then this is let's say this is C. Sorry, B I use different color for B. For B I use let's say this color lah. Tak banyak color sorry lah. Color orange color boleh lah, B. And then the C is purple color. This is C here as support. So I will apply also to this, to support number 3. Okay, to ease the calculation. So I just have to calculate 1, 2, and 3. So okay, for this, we are running out of time. So I just okay. Saya takut tak nampak lah. So okay, we break the page. Layout. Break the page. Okay, so this page I changed the setup to landscape. Okay, so this is your detailing later. So just like the slab design. Okay, I will show you the detailing. So you just sketch. Okay, sorry, this is not the AutoCAD. Okay, make sure you complete your sketch with the informations. Maybe this is okay. This is number 5. This is number 4. This is grid line number 3, and this is grid line number 1. And then please complete with your what? With your dimension. Okay. 6,000. It's also 6,000. Okay. So what to do is okay, let's say this is section. Let's say you also want to complete with section. This is section 1.1. This is section 2.2. This is section 3.3. Okay. For section 3.3 is at near, maybe near the support. Okay. Okay, so you can do later. The section is here. Section 1.1. And then here is section 2.2. And this is section 3.3. Sorry, we have. I want to take your time. Okay, just about 15 minutes more. Okay, so what to do is you design first based on the A. Okay, let's say the design of reinforcement. It span 5, 4. Let's say macam tu. Okay, so based on the bending moment is equal to what bending moment ah? A kan? Okay, 162. Okay, let's 142. Okay, A is equal to 142.6 kilonewton meter. So you proceed your calculation. First of all, of course, you calculate your D. Okay, you calculate your D. H minus C nominal minus, ini pun ada yang silap. Saya pelik betul. Minus diameter of main over 2. And then you calculate your K. Okay, and then you proceed with Z. And then you calculate your AS required. And then you go to AS provided. Let's say, for example, in this part, you have your answer is kalau apa di A ni? Kalau ni ya. Hijau, okay. So let's say your A is this green, okay. Your result is 4H20, let's say 4H20. Katakanlah, okay, 4H20 besar sangat. Let's say 3H20 lah, okay, 3H20. So, and then okay, first of all, before you design for this one, you must determine the AS minimum and AS maximum. So you kira siap-siap AS minimum ni berapa, AS maximum ni berapa, and then you can compare to make sure it's larger than AS minimum and lower than AS maximum. Okay, you compare siap-siap, and then baru you boleh buat this one. So this is your, here is your position of, this is here, sampai sini. Let's say, and then dia akan matikan lah, okay, dia akan mati kat sini, 3. Let's say this is 3H20, and then this is 2H20. Okay, kat sini mungkin 2H20 again, 2H20. So kat bawah ni, you punya section 1.1, you have 3H20 here. You write down lah, 3H20. Okay? Faham tak apa saya buat ni?
Faham.
Okay. Okay, dua orang ni dah yang jawab pun selalu. Okay, and then okay, saya buat calculation panjang sikit ya. Okay, this one. And then you calculate let's say you nak calculate mid span mana? Sorry, this is B, this is they say okay, mid span for okay, you sorry ya, your B will be here. Okay, your B will be here. Okay, this is your B. Orange color, this is your B because the bending moment is too the difference is too big, so you provide one. You can just design one. Let's say 3H20. So you can use for 3H20. Boleh juga, tak salah. So you gunakan je semua 3H20 sampai ke ujung. But for economical design, okay, so you can reduce the steel. So you spend 5 to 4 similar to 3 to 1. Okay, means because the bending moment here, okay, here 1 to 1.5 and 1 for 2 is not much differ. So span 3 to 1 also will use A design. Okay, let's say here. You can calculate to prove. Okay, but I want to do the smarter ni. This one here, 3 to 1 is here. Okay. Here is 3H20. Here is 2H20. This is the rules. Okay, if you want to see the rules of curtailment. Okay, this is the rules. This one, okay. How many percent? This one, this is the rules. Curtailment length. Okay, this one. This one, how many percentage? Okay, at this any other support, you can use 30% of out of 100%, 30% of out of 100%. So actually here, I can use 30% of 3H20. Actually, I can use 1H20 only, 1H20. So it means this is 33%. But it's very rare to use one, okay? So you use two, at least use two. At least 2 bars. Okay? So you can write down here. Here is your detail. Section 3.3.1. Oh, sorry. Section 3.3. Maybe near the support. Okay? Tak apalah. Buat di situ lah. Okay, 1 and 2. Okay, dia dah bagi siap sini. Jarak dia berapa? 0.3 L tolak 80. Ni. Okay? So you buat sini. It's okay lah. For your level, you can sketch up to this one. That is okay lah. Saya dah rasa bersyukur sangat. So this one here. Then you boleh matikan je besi kat sini. Okay lah. Nanti dia akan potong lah besi. Nanti you faham lah. So this one. Then you calculate based on the B. Okay. So the B mid-span 4 to 3. Bending moment is equal to B equal to here 94.5 kilonewton meter. So as usual, you just calculate the D, and then you calculate the K, and then you calculate the Z, and then AS required, and then go to AS provided. Let's say your result is here you got 2H20. Let's say example. So you just make sure it's larger than AS minimum and lesser than AS maximum. Okay, so 2H20 is your result here at the mid-span for this bending moment. So the color is okay. 2H20. So here, let's say here is your 2H20, okay? So 2H20 is here. Sama lah, dia akan bawa lah besi daripada sini sampai sini. Okay, 12 meter dia akan potong lah. Dia akan potong. Dan dia baru dia sambung dari sana. Dari sana, bawa sampai sini. Dan belah kiri ni, daripada 5 ni, dia akan mati kat sini. Potongan dia. And then dia potong baru daripada 1 ni, tarik 2Y sampai sini. Okay. Biasanya dia akan dekat sini lah kot. Sini sikit. Dia takkan buat dekat moment yang besar. Okay, lapping tak boleh buat dekat moment. Soalan satu. Okay, dia adalah jarak-jarak dia sebab kat sini adalah moment maksimum kan. So dia tak boleh buat lapping. Okay, tak boleh buat lapping dekat kawasan moment maksimum. Dia buat lapping dekat kawasan moment kosong. So moment kosong kat sini, which is around sini. This one. Area ni. Dah kira lah jarak dia berapa nanti. Sinilah moment kosong. Okay, dia buat lapping dekat moment kosong. Okay, and then 2H20, so section 22 is 2H20 sini. This is 2H20. Okay, this is also 2H20. And then, the last one is you calculate for the support. Support is C here. Support B sama dengan support 3. Okay. Simple calculations. Support B, B pula, 4. Okay. Support 4 sama dengan 3. So the bending moment is equal to, okay, I see here 174.3. Okay. Moment is C is equal to 174.3 kilonewton meter, and then you just proceed with your D, and then with your K, and then proceed with your Z, and then proceed with your AS required, and then with your AS provided, and then let's say here you have 4H20, let's say your reinforcement is 4H20, and then you make sure this is greater than AS minimum and lower than AS maximum. So 4H20 is here. They say in one row, okay? Here also 4H20. 4H20, here is also 4H20. Okay, just use similar like this one. Okay, this is, okay, this one, dia ada dia punya syarat dia lah. This is the distance. Okay, the distance. This is the distance. Okay. Okay. Okay, and then 4H20, 4H20. Uh, 4H20 je okay. So section 33 lah kan. Section 33 ada 4H20. So this one. 1, 2, 3 and 4. So this is 4H20. Okay, so for here we call as okay, for hanger bar, the rules is here, at least reduce to 20% or equal. 20% of tadilah 20% of 4H20 ni. 25%, sorry, okay, this one. 25%. So 25%. So dia akan bengkokkan sini, dan dia akan buat lapping. Tak apalah yang tu kamu tak boleh buat, tak apalah. Yang penting kamu boleh lukis dulu, okay? And this also, this one sama je. And then dia bawa lapping. This is also hanger bar. Hanger bar ni function dia adalah untuk support dia punya ni link. So for H20 25% saya boleh gunakan, sebenarnya saya boleh gunakan 1H20. Tapi takkanlah saya nak buat satu kat sini, satu je sebatang je, 1H20. Is impractical on site. Okay, so I change 1H20 saya tukar jadi, kamu kira lah 4H20 ni berapa dia punya ni, 1575 kan. So so divide by 4 sama dengan berapa? AS dia. This one AS kan, AS dia sama dengan 1257 bagi dengan 4. So 314. So katalah saya guna 2H16, saya dapat 402 mm square. Okay, dia nak at least 24%, 25%. So inilah 0.25 kali ni. Okay, dapatlah dia punya apa 314 mm square. So saya gunakan 2H16. So this is 2H16. This is also 2H16. Here is also 2H16. So kat sini dapatlah you punya section 11 adalah here and here. Here is 2H16, 2H16. And then what to do is design reinforcement, and then here you design for shear reinforcement. Boleh lagi ya? Faham tak ni? I hope you still here. Design for shear reinforcement. You write down lah based on V max at support 4. V is equal to this one. Yang V max kita kira tadi ni. Satu nilai ni je. 146.3 kN. Okay. Saya use green. Okay. Green ke? Okay lah. Dah ke green boleh lah. Pasal nak you tahu kat mana. Okay. 146.3 kan. 13 kN. Okay. So, for the support, let's say lah you, okay, based on your calculation, dia, okay, dia support, you dapat, your result adalah, let's say, do H8, 150 mm center to center. Okay, lepas tu dekat mid span, you can gunakan H8, let's say 300 mm center to center. So, you buatlah dia punya ni. Okay, kalau dekat support tadi, dia support green color here. Okay, here to here, near the support. This one kalau you guna AutoCAD nanti dia akan kemas. Okay. Kan dia ada kirakan jarak dia X tu berapa kan. Nanti. Itulah gunanya. Okay. Simple. Very simple. Okay. So H8 sini berapa? 150 kan. Ni ada support. So H8 150. Okay. So H8 150. H8 150. H8 150. Memanglah you dah kerja nanti you guna software, tapi saya nak you tahu macam mana software tu bekerja. Okay, dia akan kira based on section. Okay, and then apa lagi? Kat mana? Sini kan. Ni ada support. Okay, dia jarak sikit. Sebab bending shear force dia makin kecil. So H8 300. Sini pun H8 300. Sini pun you ada H8 300. So settle lah you punya beam design. Okay. Mudah tak? Okay, so the section tengok section. So si section salah satu. So you punya bentuk dia macam ni. So sini adalah H8 300. Section 22 pun sama juga sini. H8 300. Tapi section 33 dia potong dekat support. H8 150. So you tukarlah. This one. Okay. H8 150. Ini contoh je saya bagi. Sebab kalau nak buat calculation satu-satu, sampai ke malam nanti. Okay. Ini saya contoh je, result is the contoh. Tapi how to calculate the loading and how to calculate the bending moment, itu the exact yang saya bagi. Okay, so you ambil je moment yang maksimum ni, shear force ambil yang maksimum. Okay, and then what is the last steps? Check for deflection. You check dekat span yang paling panjang. So span 5-4. Yang paling panjang. You check satu je. Sudah cukup dah. Okay. Boleh tak?
Boleh betul.
Boleh.
So saya rasa you tengok-tengok balik. Saya rasa you buatlah macam yang saya ajar ni. Simple je. Kalau you nak PDF ni saya boleh bagi step by step dia. And then you contohkan. Kalau in case you punya, kan, contohlah you punya ni, in case you only have 2 span, contoh dia ada group yang ada buat design yang 2 span only. Let's say this one 2 span only. Macam ni kan, ada 2 span only. So you design macam ni je lah. 2 span je. So you bending moment, let's say maybe the bending moment is macam ni. So you design, this is A, this is B, this is C. So satu you design dekat C, and then A here, A equal to B, samakan je. Okay. So dia tak ada jauh beza sangat. So okay, you pandai lah you buatkan macam ni. Kan, lepas tu you buatlah dia punya hanger bar tadi, hanger bar dia. And this is example. Kalau you dapat, you buat second. Lepas tu you buatlah dia punya shear reinforcement. Shear reinforcement lebih kurang macam ni juga. Macam yang 3 span. Okay? Boleh ya?
Boleh.
Okay. So saya harap you boleh buat semula. Tu tak payah kira yang BEF tu this one BEF. Ini yang banyak buang masa saya tengok. Banyak calculation ambil kat situ. So tak payah. Sebab by the end of the day, dia punya moment tu, dia punya neutral axis, dia calculation neutral axis in flange. So bila neutral axis in flange, so you just design for rectangular. So buat je lah rectangular. Okay? Okay, so saya save as balik lah ni. Okay, new. Okay, saya bagi ni kejap lagi. Okay, kalau PDF lah. Okay, PDF. Okay, thank you. I will share this one. Okay, good. Okay, save my notes. Berconteng-conteng saya punya ni. Okay, so thank you very much for your participation and see you around 6:30 PM for your quiz.